居家啊，我今晚是盯着你哦。你被 M 了。上个厕所。好大个。
我全国地方谁忘记了？全国百次，我就忘记了。为啥？OK， 这种。
非常累。
对，
你现在是
对。
Hello。哎，给你们看过这张图啊？没有看过。OK，可以看一下。啊？Diamond。Yeah，Diamond。啊？什么还有指什么？
就是上次离职之前，
谁？他理智不是很好吗？
再回一下，
这个没有，
多少人？
Have you had your dinner yet？ 饭吃了吗？你们？没有啊？你们通常是几点吃饭？8点啊？8点？今天呢？今天几点吃呢？9点才吃，还会好吃一点。对。有机会喝。Okay. Okay, let's start. 啊？什么东西行？Okay, let's start. Let's resume our proof this morning. So I prove that EM cross ZN is isomorphic to ZMN if and only if GCD of MN is 1. Okay, so I already proved one direction. So there's one more direction to prove, which is from the right to left. Okay, so given that GCD is 1, GCD of MN is 1, we want to produce this isomorphism. Okay, we want to produce this isomorphism here. Right. What do you think? Yeah, what do you think? So let's see. So the claim is this product group is cyclic. So who do you think will generate this group here? What's the generator? What's the generator of this group? 来，嘉玲，选一个。几个一？10啊？10啊？10 What happen if 10 啊？10 the order of 10 is what? What's the order of 10 here? M. But how many things here? MN. Then not enough. 要不要选另外一个？11. Okay, try 11. Okay, let's try 11. Okay, let's prove what's the order of 11. Okay, so let P be the order of 11. Okay, note that obviously 11 to the mn must equals to 0, 0. Okay. Okay. Why half 啊？一帮掉是不是？这样有一点危险啊。这样的话要跟那个谁讲一下，好吧？喂，是因为我没有把它放大，对啊，我看看啊，因为这个我没有放大这个。OK， 好。OK， so 1, 1. So we want to prove that P is equal to mn. Is everyone okay with this? 1 to the mn is 0, 0. Because first spot, if you do n times, is 0. Second spot, you do n times 0. So n times definitely equal to 0. But order must be smaller or equal to this power here. Sure or not? P is the smallest positive integer such that 1 to P is 0, 0. So how many possibility here? So how many possibility here? So I claim that since GCD of mn equals to 1, there's only actually 4 possibility. Okay, so there is 4 possibility. So what are these 4 possibilities? So if P have to divide mn, what P can be? 来，嘉玲。P 如果要 divide mn，P 可以是什么 ？P 可以是 mn，good。还有一个嘉玲哎。P 还可以是什么？E good very good E divide everything 要不要问宇轩还有什么可能性？If P have to divide mn, what P can be? 什么 m？ 有什么可能性 ？Sorry？ So you can give some example to yourself, right? Like m equals to 3, n equal to 7, and then what possible? Huh? You mean P equals to m? Like this? Okay, more generally, you can discuss P that divide m. So many divisors of it. Okay, and then obviously we want it to be greater than 1 because equals to 1 already considered. Another case, we'll divide n. Okay, so I claim that these are all the possibilities. Okay, so because the GCD of mn is equal to 1, so meaning either you can divide m or either you divide n. Okay, you won't divide the combination. All right, so these are the possibility. If P equals to Mn means what? The order of my 1 is Mn. Then basically we are done. Okay, if the order is Mn, okay, if the order of 1 is Mn, it is the smallest positive integer such that 1 to the power Mn is 0, then what? Then we are done. Okay. Also more. We want to prove that the order of 1 is Mn. So if P equals to Mn, P is the order of 1, then you are done. Okay. But if P equals to 1 means what? 1 equals to what? 0, which is a contradiction. Because 1 is not identity element. Okay. How about this case here? If P divide M's, what happened? Can you draw contradiction or not? Can you consider 1P? What is 1P? Yeah? 1P. P by assumption is what? Is the order of 1, right? So meaning what? This is equals to 0. Since P by assumption is the order of 1. Okay. We call the order of 1 is P. Okay. Any contradiction or not? Any contradiction here? At the same time, what do you have? 1P is what? 1P, 1P. Right? So meaning what? We have 1P equals to 0 mod n. So what does it mean? 谁讲啊？ Who say? 摊平。So why this implies P divide n 啊？为什么？ P divide n 是吗 ？Why？ 想一下。P divide n 嘛？为什么 ？P 要 divide n？ 对。P 为什么要 divide n？ 讲一下。n divide P 还是 P divide n？ 来想一下，给你们1分钟想一下。N have to divide P. P is a multiple of N. P is a multiple of N. Usually, if you want to mod N, meaning what? I think P have to be a multiple of N, right? Huh? So let's say, so this implies that P equals to a multiple of N. And then what? Contradiction here. Yeah. So any can we contradict the GCD is 1 or not? Huh? How? Any contradiction here? There is. Nee. Why? 来，慢慢来，慢慢来，大声一点，慢慢来。来，从哪里开始？第一个 m 是反，so 我们知道 1 to the m is 0，这个 OK 也等于 0。Okay, so P can be written as M, so let's put maybe LM. GCD of MN. Why? Why? Why does it give contradiction? 讲一下。对。KN divide M. Okay, so so let's put here. So this implies that KN equals to LM, right? Divide equals then divide. I mean, sorry, 哪里前面？这个。哦，P divide M 呀，说 P divide M，所以呢？ So P divide M sure. KN divide M. 对 ，KN divide M 呀。OK，然后呢？讲一下 KN divide M. KN divide M. Oh, okay, right. So let's put here. So by so 先把这个弄掉先。So this implies that this is true. In particular, Kn divide M. Okay, Kn divide M. So Kn divide M. So by since P divide M. So this means what? So the GCD of Mn is what? Greater or equals to n. 明白吗？ Greater to the n. Or greater equal to P 啦，比较好。Because we want something greater than 1. Greater to P or greater to n? Greater than n. Greater than n only. 对吗 ？Okay, first of all, n divide n 嘛。n divide n 吗 ？n divide n 嘛？不清楚。我知道 kn divide f。n divide kn 嘛 ？n divide kn 哦。So if n divide kn, n will divide m also. 对吗 ？It's transitive. 对吗？2除4，4除8，所以2除8，对吧 ？Okay. So the common divisor between m and n is at least n. At least n. OK，把这个 n 大于1嘛？ 有危险吗？在这里啊？这个 n 如果是1的话，会有危险吗？n 不可以是1啊？n 不可以是1啊？呀，z1的话就是0。OK OK。Any question 有问题吗？问题？哎，大家 agree 吗？我们有 contradiction 啊。So here's a contradicting GCD of MN 等于1。有问题吗？Any question？没问题。OK。后面呢？后面有这样分吗？有问题吗？小月有问题吗？没问题。Any question？为什么 n 不会等于1哈？OK，你可以让它 n 等于1，但是如果 n 等于1的话，就n 可以等于1，其实 n 如果 n 等于1什么情况呢？So this is a trivial group. Okay, so if you cross product with a trivial group, then this is still isomorphic to m times 1. Zm times the trivial group still isomorphic to Zm. Okay, let me think when n equals to 1我们会去到什么情况？如果 n equals to 1，我们会去到let me see。我们就会去到这个情况吧。n 等于1的时候，你想看啊？如果 n 等于1啊，如果 n 等于1的时候是什么情况？我们要看一下我们的 order 是什么吧，对不对？If we want to look at when n equals to 1, right? So if you look at the order of elements here, there's no 1 to discuss. Correct or not? Because what's the trivial group? Trivial subgroup or trivial group here? 0. So the generator should be 1, 0. Okay, it's not 1, 1. So to discuss this 1, 1, right, you need to at least start with m and n start with 2. If it is trivial group, then it is the 0 element identity. So there's no 1, 1 to discuss. Okay, so actually here we assume. So okay, I think to be precise, so here is the case where mn is greater or equals to 2. For mn greater than 2, and the GCD of mn is equals to 1. Okay, and then we can discuss when one of them is 1. If both of them is 1, or it's the same. Okay, so all these when mn equals to 1 is a special case. Okay. 明白我讲什么吗？ Special case. Either one of them is 1 or both of them is 1. It's a special case. So here we only consider when mn greater than 2. Greater or equal to 2. Okay. So that we can get this. If you are a trivial group, you cannot find this 1, 1 generator. Because inside a trivial group only has 0. So either you have 1, 0, 0, 1, or 0, 0. Okay, imagine what's the case of 0, 0? When mn is 1. But mn is 1 here is also a 0. Here is also a trivial group. Okay, so the morphism you get is 0, 0 to 0. Okay, so now it's a hint here. Okay, so the last case is similar. So how do we build? So how do we define isomorphism? From Zm to cross Zn. So let's define this isomorphism here. Fine. This isomorphism is just sending the generator to generator here. Okay. And I claim that this is a isomorphism. Okay. Can you think why is it an isomorphism? Homomorphism should be easy to check. Is it easy? Wait. Right. I think if I tell you like this, it's not enough. Because we haven't learned. Let me think. Is it enough or not? Okay. I think I will say that define like this, as then and then. Okay. So we define. Okay. Let me put it really clear. Define a function like this, and extend it such that it is a homomorphism. Okay, so actually at first you cannot check whether it is a homomorphism or not, because I only tell you how to send one thing, but how to send the other thing? Okay, how to send the other thing? So you should observe that how we extend this. So this means we do phi on 1 to the power n is equals to phi of 1 to the power n. Okay. So we extend it such that this is true. Okay, we make it a homomorphism. This is what we call by extension. We can do this, you know why? Because every element on this side here can be written as a product of generator. Because this is what we have proven already. So from above, we can do this. We can extend like this. So we can, how about right here? So we can extend like the above, because we know that Zm cross Zn is cyclic. Okay, we can do it because we know that it's cyclic. Because it will tell us everything. Okay, we can write everything, every element in Zm cross Zn using the product of 1. Okay, so how to send this? So you just send 1 to the power n. So I give you an example. So example, how about phi of let's say phi of what? Phi of 来选一个号码 phi of what? Okay, so let's fix Zm and Zn first. So let's fix Z7 cross Z10. Okay, 7 and 10. Are the GCD 1 or not? Okay. So let's say where is phi of 3? Okay. So how do we send this across? Then what is this equal to? So first of all, you need to write your element as a power of 1 first. So how to add 什么时候加到23？什么时候？想一下。Under mod 7 and mod 10. How many times you need to add? 2? Sorry? 9? 9? Okay, so let's say if we raise it to the power of 9, the first one you get what? 9. 9 mod 7 is what? 2. Here 9 mod 10 is what? 9. I want 3 here. 10 10。还有嘞，还有什么 try how big you need 23 啊 23 okay try 23 so we check the second one first huh? 23 mod 10 is 3 good 23 mod 7 呢7 7 7 14 7 3 11 7 3 21 so you have 2 left so need 23 times okay and but we make it equals to okay actually this one is by definition phi of 1 1 to the power of 23 but how we send 1 1 we send it to 1 of 23 but 123 times what 23 okay so actually we send it to this number here does it make sense okay why we can define like this because when we define like this we know how all the elements inside Zn cross Zn get sent to because I just proved that it is cyclic okay, I just proved that it is cyclic okay or not okay any question I think later we will see this construction again in a more abstract manner now it's just a specific isomorphism between cyclic group later we'll do on free group presentation okay more general but this is the homomorphism that's defined on generators okay any question 没问题吗 okay good okay 结束了吗只有 homomorphism 哈 we still need to prove what isomorphism and surjective okay isomorphism and surjective 那你为什么 injective 呢为什么 injective 为什么 injective so to prove a homomorphism is injective what do you need to show the kernel is only identity okay so why the kernel is identity 感觉这个故事有点长了来为什么为什么啊 why the kernel is the identity I think 这个比较难 show 会不会比较难啊应该差不多一样难如果用 definition of injective so why the kernel is identity so okay 既然我们都做了还是做下去吧 so why injective why surjective 来想一下 why so why kernel of phi is the 0 surjective for every y in Zmn we want to find an x inside Zm cross Zn such that phi of x equals to y OK 哪一个比较简单 solve 我们先做简单的 right 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 okay I think surjective 会比较容易 I think surjective 比较容易 because why sorry I just take so given y is my x choose x to be 1 1 y 对吗1 1 y 为什么 why because phi of 1 1 y is what we define to be phi of 1 y times. But phi 1 we send to where? 1. 1 y time is just y. Okay. So this is how do I get this idea? Hey, 很重要 very important. How do I get this idea here? Because in the exam, maybe you need to figure out this kind of thing. Why? How do I get this idea? I get this idea here. See, if I want to get what 23, what do I do? Multiply 23 times. Okay. Why it works there? Because this is how we extend the homomorphism and how the morphism get defined. How about injectivity? Okay, this set equalities here, one direction is easy. Neither direction. Set equality, neither direction is easy here. From the right to left. Because you just need to show that 0 will get sent to 0 again. Okay. Actually, this kernel is the cross product, right? I mean, product of groups, so it should look like this. Okay, so why is it like this? Because it's also extend such that it is a homomorphism. Okay, so to satisfy homomorphism, you need to send identity to identity also. Okay, also similarly send inverses to inverses. No? So this is what we meant by extend such that it is a homomorphism. Okay, it must send 0 to 0. Okay, by construction. But how about the other direction? If something gets sent to 0, so okay, so let me write like this. So suppose, okay, so let me write here. So this is a subset of kernel of phi by construction. Okay. Okay, how about the other direction? The other direction. This is true by the construction. How about the other direction? So in this direction, you need to take any x in kernel of phi. Okay. Since this is in kernel of phi, phi x is equals to 0. Yeah. Okay. But why? Why what? So why? Okay, so why x has to be 0 in this case here. So let us. Why? Why x has to be 0? Idea? Why x has to be 0? Okay, ask another question. When can you get 0 in here? What's the codomain group here? Z, Mn. So when's the time you get 0? When you get 1 to the Mn. Okay. Correct or not? Or in other word, it is equals to Mn. Where does this come from? Or let me think how to put this. So we know that. So let's write down what we know. So x is also in Zm cross Zn. So meaning what? We know that x is in Zm cross Zn, meaning x can be written as a power of 1, 1. So let's say r. Okay, there exists an r in Z. So this is true. Okay. Yeah. So let's continue first. I'm trying to write things that we know. It's not quite a clean proof yet. So, but at the same time, phi of x is also phi of 1, 1 r times, which is equals to phi of 1, 1, the whole thing r times, which is 1 to the r. So we want 1r equals to 0. But when does 1 compose to 0 in ZMN? This r can be what number? Can be multiple of Mn. Can be multiple of N. So since we want this to be in NZM, and this implies that R has to be a multiple of Mn. Okay. But if R is a multiple of Mn means what? So there exists maybe another K in Z such that X equals to 1, 1 to the multiple of Mn. But what is this number here? I think we are done already. What's this number here? Or maybe 1, 1 to the Mn first and then K. Mn is we just proved that the order of 1, 1 is M times N. So this is 0, 0 to the K time, which is always 0. Okay, done. Okay. Is everyone happy or not? I proved that the S I pick from the kernel has to be 0, 0. Because this R has to be a multiple of Mn. Okay. Any question? Any question? From the back? K 跟 R 是不一样的东西。So, okay. So maybe 我补一个 line here, such that R equals to KMN. And so the following is true. 我找出 我找出 R 是长怎么样的。Question?问题。Question? So how do I found this R? Because I need 1 to the R to be 0 in Z mod Mn. Okay. 明白吗？ Because right, so I mean, well, maybe you can write a bit further here. This is r equals to 1 to the, so r is equal to 0 mod mn. So r is a multiple of mn. Hey, feel free to ask. No need to think so long. Either I'm true or either I'm false. Yeah, this is a mathematics class. So either true or false. That's complicated. Okay? 可以吗？全部 buy 买单嘛？买不买单？可以，第一来讲可以，其他的嘞，招生可以，还有人呢？Okay, I mean, you can ask again if you wonder. Right. So we can extend this proof to general product group or corollary. Hey, how to spell this? Corollary. Yeah, too many R, L in my lecture notes. So corollary here. So the group, if you consider, let's say, n of them, okay, if you take product of n of ZMI, this group is still cyclic, okay, and also isomorphic to Z of the bunch of M1 cross M2 up to Mn, if and only if all the Mi, Mj are pairwise coprime. Okay, so if they are pairwise coprime here. Okay, so we left this proof for exercise. Okay, so I'll give you an example. Let's say Z72. Okay, can you split it to product of two ZMZN? Hi, Jialing. You split it to two ZMZN. 多少？还乘法表哦，乘法表来啊 ？What？ What is the MN you can pick here? 99乘法表啊。9乘8 Okay, good. 98. Okay. Can you speak further? Can you use corollary or not? Let's do San, can or not? You think so? 啊，谁讲 ？Yes or no? Yes or no 啊？可以 split 掉吗？可以咩？上面讲哦 pairwise or prime， 这边呢没有 pairwise or prime， 上面有 pairwise or prime， 而且哦数目会对得到嘛 ？cardinality 对得上嘛 ？cardinality 对得上嘛？这边有72个 ，here there's a 72 elements. Here how many elements here？ 好像也对了。Okay, well, but but for sure, this one I think is not cyclic anymore. Pretty sure it's not cyclic. If you don't believe me, go back and check. What's the order of 111 here? Go back and check. Is it 72 or not? It seems like it's not. Seems like it's not. Okay, it should go to identity earlier. Okay, go back and try. Okay, I give you an exercise. Go back and check. What's the order of 111 inside this group? Okay, it should go to 0 earlier. All right. Let's go 3 more slides before we take a break here. So definition. Let R1, R2, Rn be positive integer. Okay, now I'm gonna do some cool things here. How do you guys define least common multiple? How to define least common multiple? 什么 ？LOC 不是 LCM 最大可以除以
最小
Yeah 最小 such that what?
multiple
Yeah, they are common multiple and then pick the smallest one. But now we're gonna use group language to define this. So what's the group language here? So this is the positive generator. Okay, so this is the positive generator of the cyclic group of all common multiples of the I. Okay, so what's this group here? So what exists in this group? This is a cyclic group of all integer that is divisible by all the I. All the I. For all. 想一下这句话对吗 ？OK， 想一下这句话对吗？ So what's this cyclic group? These are all the integer that's divisible by each Ri. So if you have a number that's divisible by all Ri, does it mean that this number is a common multiple of them or not? Okay, because you can take, because what? Yeah. Because 有什么好 because 的？好像没有什么好 because 的。But the problem here is the smallest the positive generator of this cyclic group meaning the smallest positive guy should be the least common multiple. Is it true or not? Being a least common multiple, do you have to be you should be able to divide all the other common multiple. 有吗？没有咩？确定？ Let's give an example. Give an example. So let's look at LCM of 2 and 4. What's the LCM and 2 and 4? 4. All right. So what are all the common multiple of 2 and 4? Let's list all of them down. 1 咩？怎么乘到1哦？ Okay. So 4, 8, 16, 30, 32, 30有吗？ 20有 OK good 还有吗？ 12 good 24 good 我们停在32就好啊。24跟32之间还有吗？ 28 good then and what? OK negative 的0有对不对？因为每个人乘0就是0。OK and then 应该就要 negative counterpart。OK because 你全部乘减一下又是他们的 multiple。OK So you see the positive generator here. You see that this 4 will generate all of them in this case. And then this positive generator here is your LCM actually. So can you prove it in general or not? Okay, can you prove it in general? Okay, we put as an exercise. I'll also do this exercise. So let's do this exercise. So prove it. Prove the LCM definition is equivalent to the high school definition. Okay, this also. But let's not do it here now. Okay. So we can use the group language to talk about this LCM here. Okay. Any question so far? No? Okay, if no, I will give the last theorem here. So let's give the last theorem. So we continue next hour. So consider an n tuple inside the product group. If we know that all these AIs has finite order, you could ask the question. The question is, what's the order of this n tuple? What do you think? 如果你知道每一项它什么时候去到 identity，then 总合起来，你知道它什么时候去 identity 吗？ What's the order？ 不是什么时候去 identity， 还要是最小的 smallest positive integer。OK？ 若星有 idea？ So what's the order of this n tuples here? What do you think? 什么时候它会一起去到 identity？ 难道要把全部 Ri 乘在一起？ If you multiply all the Ri together, right? Obviously it will go to identity. Correct or not? But the question is, does there exist a smaller positive integer that it will return identity first? What do you think? Okay, I mean, when you think of this example, 上次我跟你们讲不是这种 n 的情况你要给自己一个例子去想先。Okay, you need to produce your own example first. So what's the easiest example? Take n equals to 2 first, for example. So when you take n equals to 2, what sort of example you can take? Just now we have example like Zm. So let's put example here. I don't put the answer first. So let's say Zm cross Z 3. Okay. Take one element here. For example, what? Let's say 1, 1. You know that the order of 1 is 2 in Z2 and then 3 in Z3. Okay. Hey, this example not good. Let me change to 4. 4 good or not? 4 good. 4 is good. 4 is good. Okay. So Z2 and Z3. One order is 2, one order is 4. Okay. But obviously, if you take 1, 1 to the power 8, it will go to identity. But is there an earlier number such that both of them go to identity? What's the number? 4. Why? Because 1 to the 4 is 0 mod 2. Okay, so you get 0, 0. So how to get this 4 here? So what's your instinct to get 4 here? You need to take the LCM of both numbers. Okay or not? Okay. 8, too big. 4 already go to 0, 0. So the answer here is equals to the LCM of all the Ri. Right. So what's the proof here? So what's the proof here? What's the proof here? So what's the proof here? Actually, the proof here is very easy. Let's not write it down. So if you look at this proof here, let P be the order of this n tuples here. So you need to make every entry to 1. Okay, so to make the first entry to 1, P has to be the multiple of R1. To make the second entry to 1, you need a P to be a multiple of R2 as well. So if you want to make all the entry to 1, P has to be a multiple of each of them. Then you take the least because you want the smallest positive integer. So you take the least common multiple. Why common multiple? Because you need each of them to return to 1. And then why is the least common multiple? Because you need a smallest positive integer that works. Then LCM is the number it works. That's all. Nothing tricky here. Right. So one example is this one. If you simply want to find this order of X410 here, how to find? Don't go and expand X610, keep adding X610 because you need to add 60 times at least to get 0. Okay, so how to compute? You just compute what is the LCM of all the order here. So separately, you need to know what are their order first, and then you find the LCM. Okay, does it make sense? No. Any question? Any question? Okay, if you're gonna do it in brute force 就是真的去 test 80加几次才是 identity， 你要加到60，至少60次，看到 ？OK， 所以不要这样做。Use this LCM method. So how to use LCM method? You need to separately know what is their order first. 什么时候8会等于0？那 is that more？ 它永远不会等于0啊。我只是说什么要多少次 ？You need to add to yourself to get 0. Mod 20, mod 12. So you need at least 3 times here, because 8 times 3 is 24. So 24 is mod 0, 0 mod 12. 4, how many times you need to add to itself to get 0 mod 60? At least 15, because 4 times 15 is 60. 10. When is how much? 10 you need to add to itself to get 0 mod 24. You need 20, 12 times. 12 times is no need 24 times. Because 120 is divisible by 24. Correct or not? 24 times 5, right? Is 120. Okay, so these are the order. You just find the LCM of these 3 order here. You will find the order of your here. Okay, any question? Okay, so this LCM will tell you the order of your n tuples. Okay, any questions so far? So far, any question? Question? Sorry, sorry. 有感觉好像有很多人落单了越来越多人落单了。所以 make sure if you don't understand, please ask question. 就是听一般人就没有人还在这里，但是神没了。神的精神，人的那个我会慢慢抓一个一个抓的。So make sure if you have question, just feel free to ask. Okay. 卡住我们就直接解决吧，因为不然你会卡很久。啊，OK，let's take a break until 几点来的？现在8:16。喝咖啡。哦，不是这样玩啊。哪一个？
对，都那个是。
哪一个情况？
它可以是一个 m 的 factor 乘一个 n 的 factor，但是它
但是 GCD 和 MAT211
没有啊，但是它也可以是一个 factor 乘一个 n。我举个例子，比如说15和6，这都不是它们的同样的一个词。
等下学下15乘
15乘6等于90。
可是15乘6的 GCD，
那比如有6和6和30，
6乘30，
对，
还得1乘的话，
然后你取个，比如你会发现它是 m n 的，它不是 m factor，也不是 n。
那上面下。
6跟35啊。
你要写一下。
写一下。我上去写一下。我懂你讲么？我写一下。少情况，
对啊，你少考
真是糟糕。OK，try 一下。你说
6等于2乘3，对不对
m 等于6，m 等于几
？2、3、4、6、5、7、35。
35，所以就是7乘6。然后你说 p 要等于可能30哈。
对啊，我本来说举个10就行了，但是你说30也行。那不 n 的 factor。
我想一下怎么办呢？给我想一下。
我知道那个命题肯定是对的，但是你
我知道。我再想一下这个怎么办。OK。对，放了一个啊呀，
就是刚才那个，
来，
这个为什么p 等于 m 吗？
因为 p divide m，
那不应该是 m 等于 lp 吗
m 等于 lp。哦，反了，你是说
啊？
看一下啊。还要检查，可以把它切掉。这个是这样的话好还是不好啊？这样很好啊，这样很好啊，这样其实这个就是 p 哦 ，GCD 是大于等于 p，p 就大于1。I mean 这个很好啊，因为我一直在想这个 p 怎样 divide m 啊，忘记掉这个条件刚才。
是吗？
然后这个 p divide m， 然后这个 p divide， 因为这个又是 p 嘛。
对啊。
然后这个，对，这个 divide m，p divide n 嘛哈，还是不知道是不是 p 还是不知道能不能 divide n。从这里看得出 p divide m 嘛。
看得出啊。
但是我本来要推的东西是说 p 要 divide m， 但是好像不是 sorry，p 要 divide n， 但是好像没有这个条件。
不一定能。
这个好像没有这个条件呢。但是
反正是 p 是 n 的倍数，但是这个地方它可能应该是个等于，不应该是个大于等于。
知道它是最大的。
因为你的 great common divisor 怎么可能大于 n 呢？
哦，
你就是写的
这样可以了，这样没有离谱，因为是大于或等于嘛，没有很离谱。
我是说你这么写没错，但是我觉得你这个地方
对，可以是等于 n 啊。
你完全可以写上等于。
现在是说这个，但这个 k 一定要是等于1，你的意思是说？
对啊
，k 一定要等于1。
对啊 ，great common divisor 怎么可能大于
？No， 不是，从这边就要看得出来，是不是 ？k n 要 divide m。
对啊，
有可能吗？我想想。
从这个告诉我们 Kn 要 divide m， 所以它的 common divisor 就是 n 呀，
一定要等于。
它必须是等于 n。
哦，OK，呀，但是大于等于不用紧吗？
大于等于不要紧，但是我觉得你完全可以写上，
对，
没必要写大于等于。
是，但是
所以我刚刚跟你说的那个情况，你考虑了没？
要考虑一下。
k divide n divide k，
什么？你再讲一次？
就是如果你 k n 能 divide n，n 有两个 possibility 嘛，一个是 k 能，一个是 n 能。
对啊。
No，没有，这个纯粹就是一个 transitivity 吧。
但是这个意思就是相当于是 m 已经可以等于，比如说再写一个字母，给我来个字母，比如说 a 倍的 kn 啊，它也是 m， 它也是 n 的倍数
啊，也是 n 的倍数。
它必须
这个只是
这
个只是 transitivity 吧 ，transitivity 吧。n 要 divide kn， 然后 n 也会 divide m。
对啊，
这是 transitivity。
因为 n divided kn， 但是它也 divided m， 所以它 n 就 divided m。
明白。
OK。所以这个地方我想通过，但是我刚刚就后来在纠结你和那个
没有这一个好像确实要讨论一下。
讨论了。
这一个是什么情况？我想想，发生了什么事情？
这个我迷路了，
这发生什么事情？
要看这
我也很好去给他的脚步。
啊，
我说让神来指引你的脚步。
假设这个 P 是一些 factor 从 M 来，一些 factor 是从 N 来。
这样子你得到的这个30，它不是6的 factor， 也不是35的 factor， 但是这类情况我们刚刚没有讨论到。
对。所以怎么办呢？这个情况
在讨论。
我知道要怎么讨论，想一下。
你想一下，
还是慢一点再讨论。还有4分钟，我应该想得出。快！
我帮你点名。
确实点名蛮重要。点。
他们让何天来帮你点名，你就继续笑。
来点一下。点一下。我来。你也认得卷吗？
啊，我不认识，但是我会一个一个喊。
切。你喜欢喊啊？这个洞。就有一种方式。
你上面写这一条不是很废，这个也很废啊。
对，蛮多废东西的。
你这个证明写了很多废话。
对。
然后很口非错了。
没有。
我很奇怪，我讲我们只需要这一个，
对，
这一个就够了。
对。因为刚才乱掉，然后我想把全部东西写出来。
所以你可以稍微整理一下，我的本子卡住，你们的手上。
没有，肯定 lecture 呢会整理，只是那个时候我们再看一下有什么情况。
那写很多废话。对那一句我就觉得。
有废话，
废话写多了有时会把人绕进去的，你知道吗？
但是废话是对的就 OK 啊，废话是错的。
废话是对的，但是他可能在整一个逻辑链里面把你绕进去。
就我
对，
不明白这东西，跟我磨在那里。
确实。OK， 这个怎么办？想一下。
我觉得应该是类似的，但是我没有严格的写的。
类似出哪一个？如果 MN，OK， 应该要写上。懂这个问题。
我有点查没忙。
就算这个真的这个 case 来算吧，要让它等于00会有出问题。为什么会出问题？因为很快就出问题了。我想一下，很快就出问题了，因为你要让它。因为它如果是一半来的，它肯定是小于其中一个号码。但是如果小于其中一个号码，然后你又让小于的那个部分等于0，这样的话它 order 就不是。
对，为什么一定小于其中一个数？
也不一定。
也不一定，只是单纯这个例子是一定的而已。
给我想想，一定
不一定。
一定。
你这个地方35乘个2呢？70。
一定，因为你是抽它的 factor 出来
嘛。那我抽一个7，我这个地方不取30，我取一个2乘35等于70呢。
6和7呢？
对啊，或者6和
7，6
和7就不行了，42就不行。
有很多状况出来哦。7、6、12，确实但是肯定也有问题，因为
知道它肯定有问题，但是你刚刚说的那句话
OK， 因为你做出来的东西不是2个人的倍数。你这样子做， 我知道了，我知道了。
你的42等于6乘35吗？
哎，这样会不会可能这个就是一个 general 的情况？不一定。我知道你这样子做出来的不是，肯定是不是某一个的 multiple，
是哦，
肯定不是。
嗯，
你这样子做出来的号码肯定不是每两个的 multiple
对啊，
啊然后为什么这个跟 GCD of MN 有关系？因为如果 GCD 不是1的话，你可以从另外一个抽出另外一个 U factor。
没听懂。
OK，来，先比如说这个情况啊，比如说这个情况42啊，不管你怎么抽啊，你都不能做出它的倍数，因为你肯定是少了其中一个 factor。如果你要拿完所有 factor，就是等于你拿完整个 n 了。
嗯，
如果你要少拿一个 factor，这个 factor 是不可能从这里挖出来的，
对
所以你肯定做不出它的倍数。
对，
这个 argument 哦，
对
这个情况要这样 argument。所以就是说，
哦，
所以我要怎样把它写好出来？
逻辑懂吗？你来负责写。
一点了，可以下次解决吗？我下次解决，我下次开课的时候解决。
你写在
我回家想
讲
一下啊，写在雷圈那里，然后我下课开课的时候解决。
你在下次开课是什么？
再讨论啊？我知道很多人没有来，我看到。好，谢谢。
他用这样方法恐惧的那个，
对啊，可以哦。
可以是可以，逻辑上来讲可以，但是感觉还少了东西一样。
少吗？这是其中一个情况。我觉得下一次再讨论这个了，不先让它漏掉先，我怕等下他们听了乱乱，不要 confuse 人先。我们下谈再加这个东西进来。Okay, let's continue first. Actually, our proof in this theorem here, there's a gap. There's one case, a general case we haven't discussed, but I think we left it to next time after I write it properly and then I present it to you. Okay, there's one more case, one more general case, non-trivial case. All right, let's continue. So let's continue. All right, continue. Okay, good. Right. So, okay, let's do some motivation here. Again, okay, we take G. Okay, let's take a G here. And then let's look at two subgroups. Okay, so one subgroup is called H. The other subgroup is called K. Okay. Maybe they have some non-trivial intersection here. Either have, either don't have. Okay, but never mind. But let's say, let's say what? Let's say if you take the product of all the elements between these two. Okay, so you have H1, H2, K1, K2, and then you take all the possible multiplication. Okay. So in principle, maybe you have a larger set here, okay, formed by this H1, Hikj. Okay, so what is this Hk here? In the set notation, this is small h times small k, such that h in h and then k in k. Okay, so this is true. Okay, so one natural question you should ask is this Hk a group, a subgroup or not? Huh? Is it a subgroup? Okay, is it a subgroup or not? 觉得呢? Is this a subgroup? Or when is it a subgroup? Okay, this is one question you can ask. The other question is, can this group be the whole group or not? Okay. Can this group be the whole group or not? Okay. If can, when? So the idea here is we try to split our group into a product of subgroup. Okay, so when can we do that? Okay, the case is when can we do that? Hey, do you agree? When we form this product group, we have a larger set. We still have H because every H can be get by Hi times identity inside K. And then I can get all the K using K times identity. But we have more things here. Hi times Kj. So the question is, can we just build G using these two subgroups or not? Okay, so this is the question we're going to ask in this proposition. Let Hk be a subgroup of G, okay? And then let F be the multiplication map, okay? Defined by, because this is a product of two groups, right? So you need to take two tuples, and then where do you send it to? You send to the product of Hk. Okay, and then you look at the image set. Okay, its image is Hk. Okay, simply you just take H in H and then small k in the subgroup K and then multiply them. All right, so first thing you should establish is this map is injective if and only if the intersection is identity. Okay, quite similar to what we had before. And then this map is a, let me see, is a homomorphism. Okay, it's a homomorphism if and only if for all H in H, for all K in K, Hk equals to Kh. So when we say homomorphism, right, this means this product group is already this product set is already a group. Agree or not? This product set is a group. In the morning, we prove it, right? When we take product of two group, it is automatically a group with what LLC? You multiply component wise. Right or not? Component wise. Still remember this morning we defined the LLC on this product set. And if H is a normal subgroup of G, then Hk is a subgroup of G. Hey, did you see the difference here? This is H cross K. This one is Hk. So there's a subtlety here. What's the difference between these two things? This is a product of subgroup. Here, this is the product set. This is the image of the multiplication map. Okay, it's not two tuples. Oh, you see? See, look at these two difference here. Please note these two difference. Let me circle it for you. Look at the difference of these two things. One element is in the two tuples form. The other elements is just multiply them together. One tuple. One is two tuple, one is one tuple. Okay. But we're gonna link these two together. So D, wait, what's this? D. Okay. So D is H cross K is actually isomorphic to G. If and only if H intersect K is the identity, and then H times K is G, and also H K normal subgroup of G. Okay, so meaning what? You see, hash cross k should be isomorphic to hk. Okay. Hey, it seems like this few lecture you think they're very dry, huh? 很干是不是? But I think you have need to try to get used to it. Okay, try to get used to this kind of discussion. Okay, try to get used of this kind of discussion. Okay, yeah. So you need to understand straight away from statement. So meaning from definition. So in this D, we relate product group with the product set. Okay. So when we have isomorphism here means what? Hey, these two things should be a group already. We know that left-hand side is a group, but when is right-hand side a group? Which line tells you when HK is a subgroup? Which line above? Which line? The third line here. So you need what condition? H is a normal subgroup. Ne? That's why this if and only if here contain H need to be a normal subgroup first. Okay, so that this HK is a what? Subgroup. But to be an isomorphism, you need to be what? Injective and surjective. Okay, so you see here, HK equals to G, meaning it is surjective. Injective, coming from this intersection property, where if you prove the first line, you will know that F is injective. So that's why this condition get put together. But that's extra one. K has to be normal also. Okay, and then this is a bijection, right? But before that, you need to prove that this is a homomorphism. Which line tells you? This line, B. Okay, so you need to have that condition inside here. Okay, so every line in ABC here is to prove the D here. Okay, so ABC split out the proof of D. Okay, so the main point is D here. Does it make sense? Okay. Okay, so the main point here is D. All right. Should we do this? 看起来有没有很闷呢？还是我很闷？很闷。怎么办？放心啊，写啊，放学。等下 Peter 要把我杀掉了，放学。OK， 大家几点了？8点半。Let me think。好吃的东西？呀，要讨论什么？这么爽快啊？好吧。大家我看一下我们有什么东西要做。So 点了 ，Let me think Okay, we can discuss assignment. But how about I give you some tasks, so go back try and think about this. Okay, then we will discuss again next lecture. Okay, does everyone understand this statement here? So the most important one is this D. Okay, so to prove D, we need to go through ABC. Okay, so think about how to prove it. Okay, we will discuss the next lecture quickly. Okay. Right, in that case, let's discuss assignment. This time I bring your statistic here. Not your statistic class, I mean your assignment statistic. 你想他来是不是？对啦 ，Let me find. Okay, I bring your statistic. Okay, let's bring your assignment. Right. Right. Okay. Good. So I have your statistic here. Not on that screen. So last time, there are a few high scorer here, 19, about 19 and 20. We got a few of you. There are Adrian, Cao Qi, Eric, Yichen, Rosing, Pan Xing, Zhen Yue, and Zhao Rui. Okay, so this one is for assignment 1. And then the average is 77.5, quite high. It's distinction. Not 4.0, right? 77 is a bit lower than A, but it's good because this is average. How about the new one? So the latest assignment, the total mark is 55, and there are few of you getting 55. For example, Zhen Yue again, Dancing also, Reisha got it, and then Hong Rui, okay, Hong Rui, and then Shao Qi, yeah. Okay. So I mean, I want to encourage you, if you're not sure about part of your assignment, right? Please come to my office hour. Okay, these people are coming to office hour every time. OK，虽然他们可能不是最聪明的那一个，但是他们是最努力的那一个。OK，so please look out to these people。OK，我没有看所以你们，我是最佩服那种努力的学生，我是最佩服。OK，so I respect these very hardworking people. Not just them also a few of the others OK, like Jasmine Jing Xing or Zhen Yue Ling En also come sometime, right? Albert right? So you need to be hardworking if you are not smart. Okay, I'm also not smart, so I'm also very hardworking. Okay. Hey, by the way, that day, how many of you came to my seminar? Can I see how many of you? I know here front got, the back there got. You got me? 正月有来啊，后面呢好像谁有来嘛？谁来听我讲座啊？我看到哪一个？有 extra 10分没有？银溪，我看到银溪了。还有嘞？还有谁嘛？中间有人去嘛？周杰伦，只有银溪咩？那一边？哦 ，Raisha got Raisha also， 后面没有了哈。OK， 洪瑞有来吗？洪瑞，你有来啊？怎么没有举手啊？不要害羞。所以那天你们到底听得懂多少啊？还是听不懂？前面吧。grading， OK， 那个 category 的 part，OK， 那边比较多 technical 的东西啊。OK， 不错。Later on, we will study faithful representation in this class also. Yeah, we will get to learn this word. I mean, there's assignment of this thing. Okay, yeah, group action. Okay, good. All right. Good. Right. So, okay, let's start with first question here. Prove that A, B, and BA have the same order, such that A and B are elements of the group. So, I'll discuss the common mistake you guys make. So, the common mistake was from A, B, the order is R. You deduce that B, A, R is E. Then you say that the order is R. Done. 没有好笑 Okay, so why is it wrong? Why can you cannot deduce like that? Because the order of BA should be less than or equal to R. Okay, less than or equal to R. So you need to argue why all the positive integer that's less than R, it doesn't return to identity. Okay. Okay, why? So, I mean, let me see. So there's one person, I mean, few persons solve like this. Okay, maybe you look for internet solution, but I don't really care. But what I care is if you look for internet solution and then you just copy, then that's plagiarism. Okay, you can study solution online, but write in your own answer. Okay or not? So what this guy do is maybe let it make bigger a bit. So similarly, this guy reached the case where if n is the order of AB, BA to the n is also identity. But you need to argue that why the order of BA cannot be less than n. Okay, so if it is some m such that BAM equals to identity, you also deduce that AB will go to identity at m, okay, or n minus m here. But it is some number that's less than n. Okay, so it doesn't work because you assume that the order of AB is n. Okay, so this is one way to argue. The other way to argue is suppose you know that AB has order m, BA has order n. Okay, and then from the order of AB, you deduce that BAM is also equal to identity, so that m is less than or equal to n. And then you turn the argument the other way around, and then prove that n have to be greater or equal to m, so such that they agree. Okay, so there are two ways to do it. Actually, there's no case 2. Some of you did case 2, where the order is infinite. Because when we define order in this class, we only consider finite order actually. Seriously, we didn't define it for infinite case, but we can do that. Okay, but we didn't do it because we don't really care that much for infinite order. Because I think the infinite order that you see is, for now, is Z, right? Just Z. The order of 1 should be infinite. Okay? Yeah, the infinite order, yeah, right. The order of 1 is infinite. But, I mean, you won't care about infinite order, right? Because it doesn't equals to identity at any finite time. So why would you care about it? Yeah. So I mean, they should be pointing to other stuff, but in our class, it's not important. Right. So this is the first question. Okay. So the moral of the story here is once you get BAI equals to identity, you need to ask yourself whether this R is the smallest one or not to get to identity. Okay, you need to verify that. Okay, you cannot just look at BAI equals to identity and then you say that, oh, R is the order of BA. Because order got two parts. It has to satisfy this equality. It also has to satisfy the smallest positive condition. Okay, smallest positive is very important. Smallest positive. Okay. How about second one? I think second one, most of you get it right. You guys get it right? I think only one or two of you swap this C here. Okay, so make sure you are using the convention of matrix time column convention. Okay, if you use the other convention, it will be correspond to row time matrix. Okay, so what's the convention we use? We associate what? These 1, 2, 3, 4, 5, 6 to the standard basis. And then we look at how this matrix transform this standard basis here. Okay, I'm glad that most of you did it because the first time I taught it, it is about, I think, got 10% did the wrong convention in that class. Okay, but this class only few of you, less than 5, I think, which is quite good. So this means your ear is good. Your ears. 你的耳朵你们这个班的耳朵确实蛮好的，其他班的耳朵不是很好。知道什么意思吗？知道什么意思？对对对，有听话是认真没有听，你知道吗？他坐那边可能就是像那个一凡这样开着电脑看着电脑吧。没有，我没有讲你啊，我没有讲你不听话，我没有讲你不听话，我只是说，他真的是没有听话，他就连耳朵都没有在听着我讲，你耳朵有没有在听？有。Okay. So anyway, 就是说 yeah, I mean I'm okay if you do your own stuff, your stuff, but when you don't understand, you have to pick it up. OK， 不要在那边埋怨很难什么的，因为人家坐那边坐2个小时都做得出来，有学生在家做2个星期做不出来哦，对不对？做么何必对不对？而且我 office hour 是 free 的你们如果很有钱，不是？你们可以考虑一下给我，其实。真的，你不用给其他人，因为我真的也会跟你讲答案的。我真的会跟你讲答案，真的，我会跟你讲答案，有吗？你们来 office hour 有没有跟你讲答案？有没有？潘鑫有没有？你讲有没有？
给他钱了。
没有，重点是他没有给我钱。你看还 free， 你还不要来我的 office hour， 我都讲到破音了，你看走音还 free， 你都不要来，walao喂！我有学生真的把可能我的作业拿去给别人做800块，我心想你还不给我800块，我有答案呢。你明白吗？ So if you don't understand, if you don't know how to do, please come to my office hour. Okay, you ask me, I will guide you. Okay, 很简单的，你在我那边做2个钟，我觉得都做完了那个 assignment， 不必拉我的 deadline 的，其实没有必要。你就来 office hour 吧 ，OK 吗？不需要拉我 deadline 的，而且又不用钱哦，因为你的学费都还了，怎么你要额外还？如果你真的很多钱，捐给我。捐给我好不好？捐给我，真的很穷，捐给我好不好？不要浪费那种钱好不好？不要浪费我的钱，答案已经在我这边了，你来找我就对了。OK， 没有必要了。我虽然确实要让你想，但是如果你真的想不到，你就来 get help 罢了，很简单的。OK， 我们这边很 open 的，我们是 open learning 的，不是逼你那种头敲破头那种，没有不需要多少钱，没有必要。所以我就讲嘛，没有必要跳楼嘛，因为我都会跟你讲答案的，你跳什么楼？你自己逼自己的。什么？对跳楼也没有答案，更死。你看跳楼没有答案哦，你要去跳，我的天哪！是不是？所以我们重要是解题吧。我有答案。或者解不了问题。
跳楼就不用找答案。
但是我觉得我们觉得答案比较重要。OK，Anyway， OK 所以尽量来我们是开玩笑吧，刚才吧，但是还是希望你们有问题的话，你们来 office 吧。OK 吗？ Alright, I think the trickiest question is part B, finding the inverse. Okay, well, you can go and figure out the inverse, but there's a formula here. Okay, if you do tutorial question, you can find this formula. Okay, this inverse here is actually the transpose of this matrix here. Okay, if you use the right method. If not, I think most of you, what you do is you go find the inverse of sigma first, and then you write out the matrix form. So in this case here, actually you are using the isomorphism, okay, between Sn and permutation matrix. So actually you are using the isomorphism. Okay, if not, you can use this formula here, the transpose. Why it works? Go refer to week 2 tutorial question. Okay, please do these questions because in the revision class, we will discuss this question. Okay, so in that revision class, I won't prepare anything. You have to prepare. 懂什么意思吗？没事吗？你要准备什么？对，你要准备问题。OK， 我已经准备很多问题给你了，所以当你来准备问题给我了。Okay, you have to do it, and then you don't understand or you don't. So in the revision class, right? After you try this tutorial question, you think I still don't understand. Okay, in that revision class, we will discuss together. Okay, and then we also can discuss the concept that you miss or you confuse. Okay, where's our midterm scope? Week 1, lecture 1 to lecture 12. Okay, so everything inside there. Okay, if you confuse, then during the revision class we can go through again. Okay, and then confused, don't know how to do question, also we discuss there. And then I just put out the practice test question already. You can also do that. We also can discuss that. Okay, practice test question in the week 9 Moodle. Okay, please do it. Okay, when you do it, right? So there's a very important thing here because you are first time taking my exam. My exam is very different from the other. I'm not sure how Tao Xuan trained you, but maybe it's a bit different from Tao Xuan. What I want you to do is, if you want to get used to the vibe of my question, right? So do the practice question as an exam also. Okay? Keep practicing it. 一直做不了，就算你会，试下忘记重做。很傻啊？不会傻吧？有一点。It's good also because this question is not like once you do you remember one. Maybe 2 days after you forgot already. So very fresh, do again. So when you do it, either you can do it with cheat sheet or either you can do it without cheat sheet. So if you do it with cheat sheet, then you will get used to the cheat sheet when you come to exam. Okay, 很多学生是来考试但是带了cheat sheet 进来啊，什么东西都找不到，不知道去哪里找，不知道要用什么。So make sure you write a cheat sheet that's functional to you, because you are the one who use the cheat sheet. Okay, so for example, what you need to put into it, maybe definition or you forgot. Second, maybe some proof technique you're not familiar, put it in. Okay, so try to start and write your cheat sheet and then try and study using your cheat sheet. Okay. Yeah. Okay, good. All right, third question. Show that the definition of subgroup is equivalent. Okay, I think most of you do this question well. So because I have mentioned this in class. Right. So actually I list out the property here already. So there's a definition 1 here and then definition 2 at the bottom. So what's the difference between these two definitions here? So for the first subgroup, what do you need to have? You have a closeness. Okay, and then hash with the induced operation is a group. Maybe the ambiguous word here is the induced operation. Okay, but is it clear from context? What should this mean? Induced operation from G. So from G, there's the operation. So induce meaning you take the operation from G and then do it on H. Okay, so there are two things here. How about the definition 1? Although I didn't write it out explicitly, but actually it's stated here. There's an identity, inverse, and closure here. So you see, in this two definition, closeness is the same. Okay, but one thing that's different is the group. Okay, on one side you have identity and inverse, but inside group you have one more thing, which is associativity. Okay, so meaning what? Definition 2 has more thing than definition 1. So obviously 2 implies 1 because it includes everything in definition 1. But to go from 1 to 2, you need to prove associativity. But why associativity in H works? Because everything in H is still in G. But G is associative. Okay, so it works. Okay or not? Yeah. Right. Hey, do you know why I introduced this equivalent definition here? 知道为什么吗？什么原因？为什么在我的班很喜欢叫人家说两个东西是一样的 ？You know why？ 用完绳子。对，很会发电话，我很多东西要说是一样的。This is what algebraic like person should do. Because we play around with structure. Can you recognize two structure is the same or not? It's very important. Okay, look closely. The definition we state in the lecture. When we define subgroup, we didn't quite mention about it. What we mentioned is just close, inverse, and identity. We didn't really say that a subgroup has to be a group. Real or not? Because to be a group, it has to be associative. But turns out that automatically the subset of H, the subset H should have associativity. Subset first. Subset that satisfy all these things will become a subgroup. Oh, okay. So in this case here, definition 2 is more complete. But less complete one is 一样够用. Okay, is enough also. The less complete definition also implies that subgroup has to be a group itself. So that this subgroup is justifiable, okay? Subset, and then it's a group, subgroup. Okay, subset. Okay, good. Okay, question 4. 4a, I think all of you know how to do it. Just that you didn't mention that A and B is a subgroup, and then you can use the property of subgroup. And then I take off some mark there. 4b, actually 4b, I gave you answer in the class already. I'm not sure why some of you didn't listen. Okay. 看到太多 AB 了。Okay. Hey, okay. 4B actually I discussed in class before the submission, and I even write down the solution in front of you. So what should I say? What should I say more? 谁这边扣分啊？谁这题扣分？你呀、你被扣分了。OK， 不是 ，I mean 很多分被扣掉，不止几分。哦 ，OK， 扣一点分的也很重要 ，because you prove extra stuff. Okay, you prove extra stuff. That is a different statement already. Okay, so the logic that we've explained in class is just prove that not P implies Q. So okay, so where is the P? Where is the Q? So let's break it down, this statement here. So something unless something. So here we call it Q, here we call it P. So Q unless something is equivalent to not P implies Q. Okay, so you just prove this is enough. Okay, so if you do extra thing, I will take off mark because this prove that you don't understand what you want to prove. Okay, right. 这个在班上讨论过，是不是没有听？还是有听没有懂？平息什么？平息为什么你点头？你听了哈 ？OK。有很多人quite a few of you I already tell you the answer in the class for this question. So you can literally not copy but just write down the similar thing. 所以当我改到这题的时候，就有一点担心了，因为看到有些人没有听课了，因为答案已经摆在你的眼前了，这个是很危险的事情啊！把一个答案摆在你眼前，你都不知道是答案的话，就很危险，非常危险。就像一张$100放在你前面，你不知道那张是美金一样。You understand or not? This is very dangerous. OK, so 还是一样老话，不明白的话，请问我。OK， 因为我不能够在旁边一直盯着你，我们不是1对1教学，现在。Okay, so you have to come to me sometimes. Sometimes I can catch you, but I cannot always catch you. Okay or not? So you need to take initiative, take effort. Okay, 帮忙跟赵瑞讲一下。我叫他的名啊，他满分了。OK， 好，好吧。有没有还有满分呢？没有，赵瑞这个比较差一点的。很差咩？哦，是，你这个很差，我记得。所以我有警告你哦，你要小心哦，下次啊。你安慰一下。这个是你真正水平。OK， 这个是你的底线了，现在。说你要高过这个，下次可以吗？这是你的底线。OK 了 ，Yeah，it's right，it's fine。像你讲的，我们的 assignment 其实有很多个，其实分到下来才几%嘛。但是问题是，如果你这个不会，就代表你考试可能也不会了，这个就会危险。有 projection。So make sure after the solution get released， 你能够自己把它写出来。明白过后啊，把它写出来。OK， 明白过后把它写出来。Okay, last question is a bit tedious and I give you a lot of hint here. So what's the idea of 5A? You want to write transposition, generate the symmetric group Sn. Actually, we have proven this kind of statement in our class before. We write n cycle using product of transposition. But now I want to use different way to prove it using the row reduction here. Okay, so how do we use row reduction here? So first of all, how to relate elements permutation with matrix. Okay, this is like the question 2. Okay, we want to argue it more abstractly in this question. So for every permutation, we can associate a permutation matrix. And then the point of this permutation matrix is every row and column only have one here. So this kind of matrix, you can row reduce to identity. Because what? Row reduce to identity matrix. Why? In linear algebra, when can you reduce a matrix to identity matrix? When the matrix is invertible. Why our matrix is invertible? Because it came from an element that is invertible. All permutation is invertible. Okay. And then how do you change? How do you solve it? You just use the general statement inside your linear algebra. Or here I provide a induction argument. Every time some of you ask me how many swap you need to do, this is the inductive statement you need if you want to do it. Otherwise, I just allow you to use a linear algebra argument that you can find product of matrix of row swap. Okay, row swap matrices. But here is the inductive argument that some of you want. Or all of you can look at it if you like. Should we go through this or you can read it yourself? Here. So the claim here is this part here. Where's the claim? Here's the claim. So this is a claim. So we claim that the switching successive pair of row transforming P sigma into the identity matrix. So you can prove this using inductive argument. Otherwise, just use the linear algebra argument. It's fine. So to prove these, you need to start with a 1 by 1 case, and then you deduce for n times n case. So you see, this statement here actually is a strong induction here. So suppose that, if you look at the inductive hypothesis here, you have to assume that it is true for all k less than n. It's a strong inductive here. Okay, so we use strong induction here. Okay. Yeah. So if you have questions, feel free to ask. We can discuss again if required. Part B, the proof is similar to what we have done in class. Okay, the argument is what we have done in class. So in this, what's the statement you want to show? You want to show that 3 cycles generate the alternating group. So what's the alternating group? It's the set of all even permutation. Okay, so if it's even permutation, right? What's the smallest unit that build up this even permutation? You can break them into product of pairs of transposition. Okay, so you just need to tell me, can you use a 3 cycle, okay, to generate product of pair of transposition here? And how many type of product of pair of transposition? Okay, actually there are only 3 types. There's a fourth type in our proof in lecture notes because there's a problem where we move AB forward. Okay, that's the problem why we have 4 types here. Really, we only have 3 types here. So what are the 3 types? So first is the identity type, ABAB. Second is ABBC, so they share one common index. The last one is they are disjoint. Okay, so there are 3 types. But in proof inside the lecture, we have a second type for ABBC here, due to how we want to move transposition forward. And we have corrected in the lecture notes. Okay. Yeah, I think all of you do this part well. Either you use a function composition to show it, or either you use the string calculus that I taught you last time. Okay, both ways is acceptable. Okay, you definitely will get this kind of computation question in your exam computation twice. Okay, make sure you know how to compose a n cycle together. Okay, any other question you want to ask? So assignment 3 will be due on Friday. So if you want to get help, tomorrow is your chance, office hour. And assignment 4 is released. So you didn't see the question wrong. There are only 2 questions there. Because I know that you need to go through midterm so that you can spend time study, and then there's less time for due date, right? Because that week we have midterm, and then that Friday you have to submit the assignment. Okay, and then I will release assignment 5 also soon. Seng 没有先给你看看啦，反正还是很久的时间嘛，我就会先让你看看。So if I release earlier, meaning I have a target to reach. So you can see what sort of topic I want to reach before that. Okay, so you can do reading first, read until which part. Does it make sense? Make sense? Okay, but the due date is still the same, 2 weeks. Okay. Yeah. Anything you want to ask about your midterm or what? What's the when? I also put out the notice, right? So the revision class is on next Monday, starting from 7. Okay, starting from 7. And the venue is out also. Maybe your class representative will announce again. Will remind you guys again. But it's already on Moodle. You should check the announcement in Moodle. I already announced everything up to midterm. Okay. Any other question? Okay, if not, we'll see you next Monday. Yeah, so I will see you on the next revision class already. So please do exercise during holiday. If you have nothing to do, do exercise. If nothing to do, go enjoy. Okay. Hey.哦，conjugate 的意思是，拜拜。
只有一个 order P 的大部分。
conjugate 的意思是什么？就是有一个 G such that G 它 G inverse 等于另外一个 G。对。
这样，
所以区别的就只有一了 order，然后区别的可以
讲他们两个是
要开灯。
similar 啊，similar。
你要解。
设计很烦人类。
要找一个。
那也很烦人类。
在
那个是 cosine，不是 subgroup。但是 cosine 又不一定是 subgroup。就是它是只有一个，
没有错。
就是
order 是 P subgroup。
What if I go the other way？
也一样啊。
就是告诉
你写看。
对
P 是 prime
一样啊。
不是这个是 P 不用 prime 的。
一样。
这个也是
prime。
对。
就是 order。
你只要在这个 G general 线，然后你就可以去找。你不要 try， 你用 equation 来找。set general A B C D 这样。什么？
这个句子不 associate，我们 English 也不 associate，
就前几个咯。青色就后几个，有点危险的学生。
就这个地方英文也不 associative， 又不只是中文，真的是。
是每一个 subgroup 的
一定要的是 subgroup，
因为他们抄。
对啊，
但是它可以不一样。
对啊，
什么 rank？
对啊，
认
啊，不然。
怎
么可能不认呢？证据在哪里？怎么？
周四还是
周五啊？
周四
你写周四哦。你 set 的是
反正我
开始
我不得哈，但是那个纸上面不是
所以就不知道你到底要哪一个。
周五，我晒一下，因为一开始我是打错那个日期，
哦，
我好像是看到2025年的，没有错，然后我看错去的calendar，我会去改一下。周五。周五。
彩粉。
我想要看。
没有啊，不会差
因为一个 subgroup 跟它
不好，我觉得啊。
为什么？
这么酷？不要酷，很好。
有的是这么贝纳蒂的分数也不同的，有的5分，有的7.5，有的10。
看你抄多少多啊？
subgroup
看你考多少多啊？或者你抄4题，跟你抄2题，对不对？抄多少多 ？OK 啊，其实18、19、20些都很好，只是我找出最高几个。Yeah。其实有很多54啊，这一次很多。
这次是也有估计写上。
你可以去建立一个 bijective。
我被那个，
因为这次的那个 average 3呢，但是差的还是差的。就是这是 average 3。
因为你这里面2个不一样的元素。
代表说人家知道我要什么。所以
如果 A 不等于 A2 G A
你看
和 G A2
后了 plagiarism 还是高过3次。
两个它的等是一样的。
因为上次你只要一错，
所以这两个
你被扣一分，你就是那个占比太高了。你被扣一点
没有啊，不可能啊
你被扣几分也是那样嘛。
不可能啊，可是跟着总数扣
这是
的，
什么103.5是？
不是跟着总数扣
这两个
的。
一样的时候，它就是normal 的。
超多少？
好多题啊，
什么？
但是我没有扣很多，就是
对啊，那些抄作业的人被你
我扣
扣分了。
4题了，扣4题了，
可以追真。
除了第2题有没有是？
谁啊谁啊谁啊？
这么？那他是头，
中西哦，
他是圆头，
啊谁抄了4题啊？
差不多哎，
被扣了几分？
10分呢？
哦，才10分。
你给丢一遍抓到的话，他就直接给你。
对啊，
是嘞，
对啊，
有吗？
第一次啦，I mean
应该没有人抄我那个行列式的题，
哪边数？
真的有人啊？
不知道什么数？
我说那个行列式那个题不会有人抄。
有，不然我怎么认出来？不然我怎么认出来？
谁啊？
你继续问呢？
哪一个你的名呢？
没有
啊，
我有一个 determinant，我懒得想了，我用了那个，就是 determinant 的另一个 definition，然后后面这
然后呢？
都会啊，
那扣5还是10？
这看个人老师。
你被扣什么？
因为他很严，
是啦，
我还以为我交了，其实没有，
因为
我是有显示我有交都是
对
那边。
然后为什么
我老师就讲
一
assignment 我讲我交，然后他就
这个是
他是新的那本，他讲哦他要走白路哦，所以就扣分。
谁啊？
哦，
这
谁啊
M
太过分了，我用这个东西去。
power and 那个
加 MN 次，加 MN 次，
我是这样想，我觉
加
得
MN 次，
我觉得 mn 是 n 的倍数，然后 mn 也是 m 的倍数，
对，
所以给2个的好都是会变0。
对
这个假如就是22怎样？
这样它的 order 就要变了。
因为我也是
这么还一定会
我也不要
generate，这么一定是这个 generator。
所以因为我 prove that 它的 order 是 MN，如果它 order 是 MN，一定它 generate。
那是22。
对不起，
就不可能，不一定了了，不一定了，depend on M 跟 N 了。
那个你3跟2的话哦，
对，
你的 generator 是1跟2，
一也可以 generate，
也可以 generate，
也可以
哦
那1是最好的选择。
没有错
基。本上一在所
是咯
只要
一在所有都可以
M 不等于 n 的情况下都可以 generate 的，可以这样讲。
可以哦，所以感觉 E 都全部都
没有意义
不能
接吻
我早上不是给一个 example
哦，
吗
对对，那个
？Z2乘 Z2啊，
这个请这个是 m 跟 n 一样嘛？讲 m 不等于 n 的时候，
也不可能 Z2 加你 Z2乘 Z4
啊，这样也是不可以。
啊，也不可能。
那基本上就是 GCD 要等于1就可以了。
对呀
是能啊，
那个 proposition
啊，
对，
你查好吗？
我觉得 E 也可以，我就还讲1、2，我就只要他们是 relatively prime 的，
你别乱听思小孔啊！
哦，你说他们的 order 是 relatively prime 是不是？应该是。
放垃圾了，你丢到表的。
我只想拿走抓来。
就 GCD 等于1要 relatively prime 不是？
没有它，比如说你那个1、2怎么选出来的？因为 order of 1跟 order of 2是 relatively prime。
那3最好喝。
嗯。但是问题是现在很 general 嘛，M 跟 N 来
哪里味啊？
对哦对哦，
还有什么是 relatively prime？
不然还有什么？
什么？
这种是
啊，这种的。
有什么情况？什么号码可以 divide MN？
你错了，有拼错了。
MN，然后如果 E 的话就是 MN 哦。
啊？
如果这个是 MN 的话，等一下就乘以 E 哦。
对呀。
如果是 N 的如果是 E 的话就是 MN 哦。
他们懂啊。
对，可是不重要，重要是什么号码可以除 MN？
这样这个 P 去，这个跟这个什么关系哦？
不是，我要考虑所有的号码可以除 MN 的，有什么情况？有什么号码？有什么 P 是可以 divide MN？
可以被除被
不
M，
是
就可以被这个除。
不适合。
M 的号码就可以除 MN。
对呀，
嗯。
那么 P 要大过 E 而不然就是这个。
啊，对对对对对对，没有错。
那个是收啊，真正的。
是的。
死不死？要死不要死？
但是你们刚才在讲什么？你们
很多废话，这一句不用，这一句不用，你只需要看这一句，上面3道完就可以了。
这样这个1P 等于0，
因为
N 是什么鬼？
因为你上面都讲了，要是
什么来的？
我 assume 的。
E mod n 嘛，所以代表你的 P 可以是 n 的倍数。
哦，这个是 P 来的哈，1P 等于 P。
对，那 P 可以是 n 的倍数，所以 P 等于 kn。
对对，
然后 by 我们的 assumption kn 是 divides m。
Kn divides m。
kn divides m。
哦，因为 P 是 Kn。
对，
Kn divides
这也
m。
不是我发明的好。
然后
嗯，
然后
你想看啊？像这个跟 GCD 不是？GCD 讲的什么 m 和 n 哦，只能被溢出或者被抵除啊。算起你的 m 能被这个 kn 除。
对。
哎，我也看到没错。
那你 m 被能 kn 除，代表你 m 能被 n 除了没有？
这样 GCD 就不是自己跟 E 啊？诶，是自己。
谁是自己？
这个跟这个，
嗯哼，
然后 GCD 就是
n 吧，好吧。
嗯
就是这个 n 啊，这个是
嗯
这样是吗？
啊，
对，
你是讲
嗯哼，
这两个的 GCD
嗯哼，
有 OK
没有，什么是 GCD？
共同的，
divisor 吗？所以 n 肯定能除 n 吗？现在 n 也可以除 m 了，
因为这个，
因为 n 可以除 kn，就这样。
怎么他们就讲这个是等于什么鬼？
因为你想一下，这个 GCD 如果有大于等于 n 是什么意思？可能会大于 n 嘛？如果这个 GCD 大于 n 的话，还可以除 n 嘛？你啊？就是你的
GCD 怎么可能能大于
你的 divisor 会比你原来的号码大吗？
比较大除变 fraction 了，
不能，
不能哦，所以最大就是 n 了。
最大是 n，最大 n 不是这样吗？
这样，
不是，是对，
他写
不是他的意思是从这个式子推过来的是大于等于，同时它小于等于是必须的，所以它是等于。OK，
也可以这样讲，
如果你去叠这桌子，我操，难
因为
怪。
它有铁啊。
因为这是铁是西点式。
所以你讲
你要去
回房间了，这几点？拜拜。
这个
咋了？咋啦？
m 跟 n 的 GCD，
啊，
哦，这个一定要大于 n，
也，
不然它就变成 fraction 了。
如果它大于 n，
那就
对，
所以它这个 n 小于这个，所以它一定是要等于。怎么 n 要小于这个啊
CD 吗
？GCD 是
？With
不会大于那个号码的吗。
不会大于 m，也不会大于
divisor 哎，
小于等于 m，小于
那个加绿色是啥意思？
哪个是加绿色？
那个加绿色，
拜拜，
拜拜。
就是你那个上面加绿色。
我帮你怎么扩大你的社交？
就是你那个表格里面加绿色的是啥？
就
算了，我就本身会跟他聊。
一个人啊，
加黄的呢？
加环呢就是 top 几个
哦，然后那个啥呢？
啥？
后面那个扣分的就是抄作业。
对啊，
这是什么？
减5是什么意思？就是
也是在
抄
抄吧？
你抄的比较少，你就被扣分；抄的比较多就扣分。
到底是谁那个行业是抄我的？我很好奇。
因为你超多，你一定是 advantage 比较高嘛，
这是什
当然
么？
要把 advantage 拿掉了。
啊，这个就是把1到1 maps to 1啊。
就是它 define 啊，这个 define 的不是咩
啊
？define 1去1哦，
这个是自己 define 的。
自己 define 的嘛。然后我就 extend 哦。
考试会不会有没有要叫我们自己 define 东西，然后自己去做？
可能有。
你要是考一个两个东西是 isomorphic 的，不就需要你自己去找 isomorphism？
对，
举个例子。
对。
isomorphism。
可是你要去找一个基本的，容易啊。
isomorphism 是要真 ，d 还有
homomorphism。
homomorphism 是要真。
VA
Vx
把 AB 等于
Vx 加 y 等于 Vx 乘 Vy。Vx y 等于 Vx 乘 Vy。
那你不 encode？看 everything is such that